In today's video, we'll take a look at how to recreate from scratch the Cryonis Rune from the Legend of Zelda Breath of the Wild. Before starting, if you want to see more videos in the future alike, consider subscribing to stay up to date with everything. Big shout out to Xeon, Donald Anderson, Kamasutra Industries, Ben Lewis and Andrew Milspog for supporting me this month. Thanks a lot guys. And now, without further additions, let's see the steps you need to take to replicate this mechanic. First things first, what we have to make sure we do is that we have a water material. This can be whatever liquid, or it can even be solid, but make sure you have a material that is going to represent where you can use Cryonis. Okay, now let's create a blueprint class and an actor. I'm going to call this BP_Cryonis. Right, let's enter it and start adding some components. The first one is going to be a scene, and it can be by default here on the grid. Then let's add a cube. Now make sure that this is attached. Let's scale the scene to 1.5, 1.5 and 0.02. Okay, now let's make sure that the cube is placed on the grid. So this green line here is going to be right on the bottom face here. So this is pretty close, it's close enough at least. Now let's set the collision to no collision. We really don't want collisions for this one. Now let's add a box collision. This one should be slightly bigger than cube. Just a little bit, not too much. Make sure, just scale it. And when you can see it, that's fine. You know, on the Z-axis as well. Alright, this is good enough. And then for the collision preset, let's set this to overlap all. Okay, so now let me explain why we had to do this. If I'm now going to scale the scene on the Z-axis, you can see the cube going upwards, which is exactly what we want. We want the cube to go upwards every time. We don't want it to go downwards. And of course you can see it going downwards a little bit because it's not perfectly placed on the grid. But by default, the cube, if you scale it on the Z-axis, it is going to be scaled on both axes, right? On positive and negative, which means downwards. We don't want that, we only want upwards. Okay, now on this scene we also want to add a plane, which we are not yet going to tweak. Just make sure that the collisions are no collisions. Now to this cube we want to apply a material, something that is going to show the outlines and a little bit the interior of the faces. So I already have my material here. I did it with the help of the Tron-like material tutorial by Leah Red. So here it is, this part right here is the tutorial. And then I added some things that will give me this effect of pulsation, right? The glow that is pulsating, and some other effects which I'm going to explain right now. So after multiplying with the glow strength, I'm going to apply this right in the emissive color. Right, which also the material is double-sided. After plugging this in here, I masked the red color from the multiply, so I have a float. Right, I don't have a vector 2, I have a vector 1, which is a float. Then if this is bigger than 0.3, I'm going to set it to be 1, so I can see the outlines. Right, the red is going to be almost every time bigger than 0.3. But if it's equal to 0.3 or smaller, I don't want to be able to completely see them. So this is why you can see this effect here for the opacity. So I'm going to multiply the result from here with a sine node, which looks like this, basically from 0 to 1. And I'm also going to clamp this to 0.2 and 1 maximum. So I'm not going to have completely black, I'm going to have a gray value. And I'm just multiply this and plug in opacity. You can also have an instance with some special properties which make it look better. Here, so color blue, edge sharpness 30, edge subtraction minus 0.08 and glow strength 34. And by putting this on the cube, it is going to look the following. Right, what you can see here white is the plane, so let's also make a material for that now. So, new material, m_snowflake. But before creating this material, I have to import an image, so let's do that real quick. This here is going to be my snowflake. It's done by me in Illustrator. The link to it is going to be down in the description if you want to use it as well, or you can create your own. Doesn't really matter. Let's create the material m underline snowflake, and this one is going to be masked. What we have to do is to drag the snowflake in here using the last pane, plug this in opacity so we can only see the snowflake. Right, so in a second you can see right here. Then let's multiply this with a color. I'm going to have here color, a blue color indeed. Right, and also before multiplying the color with a texture, first we have to multiply the color with a constant. That for me is going to be 25. Now we are going to have emission. If we are going to preview, you can see emission on the cube. And by plugging this multiply in the A node, we are going to get the following result. Currently you can't see it, but after we plug this in emissive color and we stop previewing it, you can see that we are only going to have the snowflake emissive, which is exactly what we want. Now let's save. And we should go in the blueprint and set this material to be on the plane. From blueprint, okay, select the material, go to plane and put it on the material. Now this is how it looks. Of course you can scale it up or down so it fits. Right, now we can go on and set up the event graph. First thing that we'll do in here is to create two new variables. First one is placed, and second one can be placed. Both booleans, but the second one can be placed, should be true by default. This new custom event called expand/retract. And let's add an input. I'm going to call this expand and a question mark. And the first thing that we need to do is to have here a branch, and we want to check if this is placed. But first we are going to negate it using a not boolean. So if this is not placed, which means true, we are going to do something, but if this is placed, we are going to do something else. You'll see once we get there. And if this is not placed, we are going to check if we want to expand. So if we want to expand it, again, we're going to do something, we're going to expand it, of course, but if we don't want, which means we want to retract it, we are going to do something else. So from true, let's add a timeline. We'll call this retract/expand underline timeline, and we always want to play from start. Let's get into it and check looping, and let's get a float track called lerp, and let's add two new keyframes, time 0 value 0, and here time 0.8 and value 1 as well, length 0.8. Now you can always play with the time. You can set this as long as you want, but don't play with the value because we are going to use this for an interpolation, and interpolations goes from 0 to 1. We don't want to have more than one here. Okay. Then what we are going to do is to go from false. We are going to get here a sequence. Okay. From then 0, we are going to stop this. And from then 1, we are going to set the scale of the scene, so set relative scale 3D to be its default values. So, split extract bin and scales, we copy them from here, 0.1, 1.5, 1.5, and 0.02. 1.5, 1.5, and 0.02. And this is because once we want to retract this forever, right, so it's not going to play that animation anymore and it's going to be static, we want to set the scale, basically the scale of the cube, back to its default value, but we're going to change the scale of the scene for the same reason that we are going to attach the cube to the scene. So it is only going to be scaled upwards and not downwards as well. Okay. Now let's get from the lerp here. We're going to have an interpolation float. Let's see. Lerp float. The alpha is going to be the lerp, and A is going to be 0.02, and B is going to be 1.5, right? So A is always going to be the default value for the Z, and then B is going to be as big as you want the cube to be. Then we are going to get the scene once again, set relative scale 3D, apply this in update, put the struct pin, X and Y once again by default 1.5, their default value, because we don't want these to change, we want them to be static, so it's always going to be the same, it's going to be as wide and as lengthy as it was by default. The return value goes in the Z, and then we are going to set can be placed to be true. Because if this animation is going to be played, we want, so the animation of this going upwards and downwards every time, if this is going to be played, that means that we can place Cryonis. But if we don't want to expand this and we want to retract it, that means that we are going to set this to be only one value. It is not going to play the animation anymore. Can be placed is going to be false. Right, false, not true. Make sure that you don't mess this up. Okay, now there are some things left that we have to do for this custom event. First of all, from false, what we want to do is to get a timeline. So if you didn't know, you can get a timeline variable, right? And set looping to false, right? And I'm going to explain in a second why we want to do this. And then as well from here, go to play from start. We are going to call this custom event at some point when we want to place the Cryonis, but before doing that we are going to set is placed to be true, which if this is true, by negating it, it is going to be false, which means that when we are going to place it, the branch is going to be false, which means that the new looping should be false as well, be careful, which means that we only want to play this timeline only once, last time, once it is going to be placed. Okay, then from finished, we need to get a switch on, actually in fact we need to go from direction, switch on E timeline direction, which goes from finished, and on backward we are going to call here destroy actor. Yeah, and first once again we need to create a custom event called destroy, which goes in reverse from end. So our player is going to have a limit of how many Cryonis runes he can use. I want it to be a maximum of 3, because I believe that's how it is in The Legend of Zelda. And after the limit is reached, so we have 4 pillars or Cryonis runes in the world, we are going to call the destroy custom event, which is going to reverse from end the pillar, so it's going to go back down, and we are not going to be able to see it anymore. And once it's done going back down, we are going to destroy it because there's no need for it to be in the world. It's only going to occupy memory, which is not good. We don't want to have unused memory in blueprints especially. Okay, now let's go to the box and get begin overlap and end overlap. On begin overlap, what we want to do is to make sure that the other actor is not equal to the player character. So we want to make sure that the other actor is not equal to get player character. Alright. But as well, which means that we need to get an end boolean. As well, we want to make sure that the other actor get class. We want to make sure that the class of the other actor is not equal to the water actor that I have in my scene, right? Because I want the box to ignore the overlap with the water and with the character. So if both of these are true, right? So if the overlap element is neither the character, neither the water, we are going to call expand retract, but we are not going to expand, which means that we are going to retract it, which means false. Then let's copy this again. The same setup. Okay, but this time we are going to expand, right? Then as well, on begin play, actually first let me explain this. Once the overlap is going to end with anything that there is in our world, that means that we are going to be free to use the Cryonis, which means that it is going to play the animation of expanding looping. Now from begin play, we are going to call once again expand let's retract, and by default we are going to expand this. Right, so once we are going to press button to use the rune, we will want to make sure that by default this is going to expand, because anyway after we are going to set location of the Cryonis, it is going to update the collision for the box, and so if there's anything that collides with it, it's going to retract here. Okay, I think that is basically everything we have to do in Cryonis. Now the last things that we have to do are in the blueprint, or in the blueprint of our character. First thing we'll do is to go in edit, project settings, then we are going to go to input, action mappings, I'm going to call this use rune, and I'm going to bind it to my E button. Bind E button, close it. Now I'm going to get here use rune. Now when I'm going to press E, I'm going to be able to see if I want to use the rune or not. So let's get a new variable here. It's going to be called is using rune. By default is going to be false. So we're going to see once you press E if I'm using the rune. But first let's negate it, just like we did in the other blueprint. If I'm not using rune, if I'm not using any runes, what I'll do is to set this to be true, and then let's create, for now let's just create it, and I'm going to explain later why we are going to do that. Material parameter collection, water collection, okay, color parameter, I'm going to call this let's see, emission, I think that's good. Okay, so set scalar parameter value from the collection that we just created, parameter name emission, and the value is going to be 25 again. We're going to use this later, so just create it for now and I'll explain then why we do it. Okay, then here we are going to have set timer by function name. For now we are not going to set the function name, let's just set the time to 0.01 and check looping. Let's get it from the return value. Let's promote this to a variable. Call this rune timer handle. Okay. And then we are going to create, we're going to spawn actor from class, and the class is going to be the Cryonis. Will be Cryonis. For the spawn transform, just leave this by default. Really, it does not matter the location or the rotation for now. Then we are going to get a return value and promote this to a variable. I'm going to call this pillars. Delete it from here, from the graph. Then let's set this to be an array. So we are going to add to this array the return value. So we are going to have a reference to it, and as well promote the integer here, the current pillar. That is because we always want to know what pillar we are going to use right now. So as I said, I'm going to have a maximum of 3 pillars. That means that we can have 3 possible values, 0, 1 and 2. And we always want to know which one we want to destroy. Okay. Now we're going to have to set the false part from the branch. Okay, and as well, here with the set timer by function name, the function that we're going to put in here is going to have a line trace which is going to go in front of the camera, so we want to see where we want to place our Cryonis. But since we won't create it yet, just leave this empty, and we are going to do that when we are at that part. Now let's see what we do with the false part. What we are going to do, get these two and reset them, so is using run back to false and parameter value back to 0. And as well, one thing I forgot to explain is this right here. This branch with a boolean is basically a flip-flop node, right? Because the boolean value is going to change every time, right? So it's of course going to be a flip-flop, but by using this method instead of a flip-flop, we are going to avoid some errors that we are going to get later once we are going to set the is using run variable outside of this action. Okay, then let's check if the run timer by handle is valid. And if that is true, so this timer is still playing, we are going to clear and invalidate the timer by handle. Alright, this looks good. And from the clear and invalidate timer by handle, we are going to get both the current pillar, so get it, and we're going to get the array as well. We are going to destroy, let's see, we are going to get a copy, and the index is going to be the current pillar. And then with this copy, we are going to destroy actor. And as well, let's copy this one more time and remove index with the same index as the current pillar. So let me explain this. Once we are going to press E, we are going to spawn the Cryonis, which means that this is going to be somewhere in our world, and it is going to occupy memory in our system, right? But then if we suddenly decide that we don't want to place the rune anymore because there's either no space to do it or it's unnecessary, then we want to make sure that we are going to destroy that unnecessary Cryonis, right? And that we also remove it, that we are also going to remove it from the pillars, right? So this should be fine for this part. Now let's create a custom event. I'm going to call this Cryonis setup. Really doesn't matter the name. And this one is going to go in the function name, compile, and that's it. Now let's see how we are going to set this up. The first thing that we are going to do is to have a line trace by channel, right? And now we are going to get the world location of our follow camera. This is going to be the start of a line trace. Get forward vector, multiply this with a float. For me that is going to be 2000, and then let's add these vectors. So this way the line trace is going to start from the world location of the camera and it's going to go in front of it 2000 units. Let's call this into a macro. Call this camera line trace. Let's get into it, or we can set the outputs in here. The first output is going to be start and the second one is going to be end. So these are always going to go in their pins here. Okay, then we're going to have a branch. So if we hit anything with this line trace, we're going to do something, but first let's set up the false part. We're going to get pillars, and from pillars we are going to get one of the pillars in the array, and that one is going to be the one with the index from the current pillar. Get root component, and then set visibility, propagate to children, no visibility false, and set it. Okay, the reason that we do this is because if we don't hit anything with our first line trace, then there's a chance of us being close to these coordinates of 0, 0, and 0. And so the pillar is going to be visible at that location, right? But it is not going to move, so it's going to look weird. And by setting the visibility to false, we're going to avoid these errors. As well, let's create a variable, a boolean. I'm going to call this can place pillar. By default, it should be true, and set it here to be false. So if we hit error, we will not be able to place the Cryonis. But if this is true, we're going to break the hit result. Let's set this down here. We're going to break the hit result and see if the hit actor is our water. So cast to water actor. And so if water hit is water, we are going to do another line trace. Okay, start and end the macro that we just created. Okay, but this time we're going to have to set the actors to ignore. Make array, and what we are going to ignore is the water that we hit, right? So we don't want our line trace to collide with it anymore. Okay, do another branch, and let's break the hit result. Let's break the impact point and then add to the z-axis 1. Then let's make vector and then plug this node in a z. And now let me explain why we are going to do this. So this make vector is going to be the location where the Cryonis is going to be, and we are going to add 1 on the z is because our plane with a snowflake is right on this grid. which means that sometimes the snowflake is not going to be visible if we don't add anything, because two surfaces are going to collide with each other. Okay, now once again we copy this, the pillars, current pillar and get, and we are going to set actor location. The actor location, as I said, this make vector, then set visibility. First we have to get scene component, get root component actually. Okay, then set visibility, propagate to children again, new visibility true, and then can place pillar to be true as well. Now let's see if this is working. Okay, so as you can see, there is our Cryonis. You can see the animation playing that is going upwards and downwards every time it finishes. Okay, if we are going to collide with this cube to the left, it should stop. So as you can see, it indeed stops. Let's check with other ones as well. So with this one, it doesn't stop. Let's check with this one. So with this one, it does stop. Probably there's something I forgot to set here. Let's see. Maybe it is because they are grouped. Group. And the problem is that we don't have generate overlap events to be true, but for this one we do have. So make sure that you have generate overlap events to be true, otherwise this is not going to work. Now let's test one more time just to make sure. As you can see, it is working, but for now there's nothing happening. Now one last thing we have to do before actually placing the pillar is that we have to create that effect on the water using the set scalar parameter here. Let's see how we can do that. First, I'm going to open the material from the water. So I'm going to open it here. Okay. And the first thing that I'll do is to get a texture coordinate. Then I'm going to multiply this with a scalar parameter, text coordinate. Okay. And the default value is going to be 5. Going to multiply. So this means that we are going to have 5 times scaling of the texture. Then let's get a panner. Plug this in the coordinate. Time is going to be the time node, and the speed, it is going to be 0.6 on the Y. Now it's time to get a texture sample, but first let's just put this in here. Okay. Then we're going to multiply this with a parameter collection. We're going to multiply this with the emission parameter from the water collection. So this is why we want to set this in here with 25. Right? Then let's multiply this with a color, the blue color. Right? You can set whatever color you want, remember? And then we can multiply once again, final multiply node, multiply everything with the base color, and then plug this in the emissive color. Now we are going to get an error with our texture sample, so let's see what texture we have to use. So for this one, I'm going to import a new one. Here's my texture. This is something that tries to imitate the effect on the water when you use the runes in the actual game. So let's just place this in here. I can't really explain what I did for it. Basically, I'm going to have here a gradient that goes from gray to something a little bit lighter, back to gray. And then I'm going to have these bars here. Everything is seamless, and as well this texture is going to be in the description. So make sure to get it if you want it. Compile, play, now let's press E. So apparently nothing is happening, and that is because we haven't compiled. Okay, let's wait. Okay. Just a little bit more. And then something that we might have to change is the panner here on the Y. Maybe we should put 0.6 on the X, but first let's see how this looks. You can clearly see the water that it's still compiling. So let's wait a little bit. Okay, it compiled, play, and now you can see the effect. You can see the bars, you can see that gradient, the blue here, that goes from right to left. The banner is done, right? There's nothing we have to change in it, which is good. Right? And now the only thing that is left to be done is the placing of the pillar. So let's go to project settings. First we need to get an input, new action mapping. I'm going to call this fire. Okay, and it is going to be bound to the left mouse button. Okay, fire. And now we need to create some branches. First one is going to be is using rune. If we are going to use the rune, we want to make another check. Right? This one is going to be can place pillar and boolean get pillars, get copy. The copy is going to be with the current pillar, can be placed. So if we can place the pillar and the pillar can also be placed, this seems weird, but not that much weird, because as you saw in the blueprint for Cryonis, we have this box which sets if we can, if the pillar can be placed. And then we also want to see if the player can place it, if there's nothing wrong going in here. If that's true, we're going to set is using rune back to false. And this is why we don't want to use a flip-flop, because this is where we set this back to false. And with a flip-flop, this would not work properly. Then let's copy the set scalar parameter value and set it back to 0. Okay. Then we can also copy this, place it. Now there are still some things we have to do. It's not yet done, but we can check if this is working or not yet. I'm going to press left click. And some of the things resetted. You can see the Cryonis is not moving anymore because we have here clear and invalidate timer by handle. There are still clearly some things that we have to do. Okay. Now once again we need to get this, paste it in here. First thing we need to get cube and set material. We are not yet going to set it. Then as well set is placed to be true. Okay, and as I said when we created the Cryonis blueprint, the new reroute for now, as I said, after we're going to set this to be is placed, we are going to call to retract or expand, and we're going to have this to be false. So let's take a look and see what this means. So we are going to have this placed, which means that this is true. By negating it, it is going to be false, which means that we are going to run this path. Okay, so we are going to set the is looping to be false, and we are only going to play this once from start, which means it is going to play the animation only once upwards. Okay, and then we need to get the cube one more time, set collision enabled, with collision enabled, then we need to get the box collision that we have here around the cube, and then set the collision for this one to no collision, because we don't want this to be able to detect anything anymore. Okay, that thing that we have to do is to see if we have too many pillars. That means that we have already 3 pillars, and if we want one more, because if that's the case, we will want to destroy one of the pillars. Let's create a function. I'm going to call this pillar check. First I'm going to call this in here, right, just so we make sure we don't forget. And in here, get the pillars array, get the length, right? This is going to represent how many pillars we have in the array. And if this is bigger or equal to 3, if this is already equal to 3 or bigger than it, then what we'll do, I have here a branch of course first. So if this is true, we're going to get pillars, get a pillar with the index of 0. We are going to call destroy, not destroy actor, but the destroy function that we created. And then from pillars, we are going to remove index. So we are going to remove the pillar from index 0, and then all the pillars are going to go. So the pillar on index 1 is going to go to index 0, and the pillar on index 2 is going to go on index 1. Okay, now only one thing left to do, I believe, is to set here a material. And I already have my materials in here. They are from Advanced Glass Pack. Go to materials, alright, and I want frozen examples. Let's see this one. Let's wait for it a little bit to compile. Then we'll have to change some values in here. Of course, for this material, once again, you can use whatever you want. It really doesn't matter. It's just for the visuals to imitate the game as best as I can. Right, let's wait a little bit for this to compile. So as well, you can have, I don't know, you can have again another liquid, or you can literally have whatever you want. Doesn't matter. As well, for these materials, you can play around with everything that you want, mostly in this mechanic. I'm going to change the colors. This is too bright. Okay. Then the opacity 0.95 and 98. Okay, then I'm going to change the refraction. No, that's alright. Roughness 0. I don't really know how much of this snow I want, so let's see. Okay, contrast 0.5 and frost intensity 0.3. Maybe. What about 0? I think that's alright. I think that looks good. Anything else in here that we have to change? No, I think that's fine. Let's select it, make sure that we have it selected, put this in the material, play, and now let's check if everything is working fine. Once again, here, when I press E, this is going to pop. I'm going to press left click. You can see it happening. Of course, now you can go on and change all the values that you want. Maybe 1.5 is not enough. Let's be to 3, and now this is a lot bigger. You can see. You can also see the snowflake there. If that's not good for you, you can go in here, set the opacity to 1. Okay, now play, and you won't be able to see it. Or you can even destroy the plane after placing it, but I don't want to do that. Of course, again, you can use whatever you want here. And that's pretty much everything we have to do. And that's it for this video. I hope that this mechanic was interesting to recreate and that the video was helpful to you. Let me know down below if you have any other questions regarding the tutorial and I'll make sure to answer them. If you want to see more videos in the future like this one, consider subscribing to stay up to date with everything. For Patreons, the project files from this tutorial will be available over my Patreon page. Last but not least, thanks a lot for watching and I'll catch you in the next one.